I know. I'm sorry. That was a really important conversation about non-board business. Good morning. And good morning and welcome to this informal workshop to receive comments and helpful suggestions regarding the Delta Science Program's independent review committee report titled Recommendations for Determining Regional In-Stream Flow Criteria for Priority Tributaries to the Sacramento-San Joaquin Delta. I am going to need another cup of coffee, I think. Sorry. I'm Felicia Marcus, Chair of the State Board, and with me today are Vice Chair Fran Spivey-Weber and board members Tam Doduk, Didi Diadamo, and Steve Moore. For those of you who have been with us, bear with me as I repeat the evacuation procedures for anyone who hasn't been here. If you hear a loud sound that is sounds like an alarm bell, it is. We find the exit nearest you, take your stuff, and then we evacuate to Cesar Chavez Park. You can go wherever you want. If you want to know when the all clear comes in and you can come back in with us, you might want to be with us out there. Please set your pagers and do people still have pagers? I don't think so. So whatever the things that make noise, set them on stun or silent or turn them off. And know that, is this being webcast and recorded? It's being recorded. Webcast too? How nice. So the trick is, and I'm not good at this, if you get closer to the microphone, more people can hear you. And even if the people in the room can hear you when you're a little further away, it is a little difficult for folks on the webcast. I know it's hard to do. I don't like it. And my colleagues have to remind me when to get close. You'll see people waving things at me, or that's what they're doing. But please try to do that. I think that's the main stuff. Did I forget any of those things? Announcements? Great. Okay. We will, I'm not entirely sure how long this will go, depending on how it seems to be going. I will most likely take a 15-minute break somewhere between the 10 and 11, more like between the 10:30 to 11 time frame, just out of courtesy, and so people have a chance to get some coffee. I will, I know. And then we'll come back to business, and we'll take, if it goes that long, we may go through noon, but by 1 we would be taking a lunch break if it appears that we will be going much past that. The workshop's being held in accordance with the public notice dated February 19th, 2014. Just a reminder, this is an informal workshop only. We're not going to take any formal action. There'll be no sworn testimony or cross-examination of participants. The board members and its staff may, however, ask clarifying questions of the speakers, and after receiving comments at this workshop, the State Water Board may provide direction to staff regarding future activities. We're also going to receive public input on the committee's recommendation of the method that the State Water Board should use to develop flow criteria for priority tribs to the Bay Delta, and interested parties may review and comment on the committee's recommendation or provide alternative recommendations of the methods to develop flow criteria for priority tribs to the Bay Delta. This workshop will not be transcribed, so interested parties are encouraged to submit their comments in writing. Comment letters regarding this workshop must be received by noon on Friday, April 18th, 2015. Okay. Do people have an agenda of this in the back they can pick up, or it's just what I'm about to say? Okay, so let me just... Okay, terrific. So let me just explain the order of proceeding for those of you who are listening and those on the webcast. We'll hear a short introduction from the State Water Board staff, followed by a presentation from the Delta Science Program's Independent Review Committee Chair, Dr. Cliff Dahm, the former Chief Science... What was your title? Chief Scientist for the Delta Stewardship Council, and I had the pleasure of serving with Dr. Dahm when I was on that council. Following these presentations, we will hear comments from the public. If you intend to speak today, please fill out a blue speaker card and give it to the clerk. Give it to Janine, right over there. And if you're not sure whether you wish to speak, please fill out a card and mark it, quote unquote, if necessary. I think that means when it gets to your turn, you can tell me if you feel that it's necessary or not, because I'm not going to judge whether you think it's necessary or not. In order to ensure that all participants have an opportunity to participate, oral presentations from any interested persons may be limited to 5 minutes per speaker. Okay, let's get going. Water Board staff, Erin, please introduce your colleagues and take it away.
Good morning. I'm Erin Ragazzi with the Division of Water Rights. I'm the Program Manager for the Water Quality Certification and Public Trust section. With me today are Dan Schultz. Dan is the lead of the Public Trust Unit, and Dana Heinrich with the Office of Chief Counsel. To my right is Dr. Cliff Dahm, and he will be providing the overview of the recommendation. As mentioned, the purpose of the workshop is to receive information and solicit public input on the recommendation developed by the Delta Science Program's Independent Review Committee regarding a method or methods to develop flow criteria for priority tributaries to the Delta, which is also known as Phase 4. To assist interested parties in providing comments, I will provide a brief overview of Phase 4 of the Bay Delta effort, and then Cliff Dahm will provide an overview of the recommendation and findings developed by the Independent Review Committee. The purpose of the presentation is to provide an overview of Phase 4 of the State Water Board's Bay Delta effort. I will first briefly provide an overview of some of the definitions and key terms relative to the discussion today to make sure that we're all on the same page when we're talking about these key terms. Then I'll cover general background regarding the State Water Board and its authorities, and then provide an overview of the Phase 4 process. For those who don't know, Phase 4 deals with developing flow objectives for priority tributaries to the Delta with a focus on the Sacramento River. Then I'll provide a brief overview of the next steps and some resources if folks want to stay tuned over the coming months and years as this process moves forward. So some key definitions. We're going to cover flow criteria, flow objectives, public trust, and beneficial uses. The focus of today's workshop is the development of non-binding flow criteria. Flow criteria, as referred to in Phase 4, provide the technical basis for the development of flow objectives, but do not have regulatory effect. Flow criteria do not consider the cost of providing this water or the competing uses of water. Flow criteria will identify the range of in-stream flows needed to ensure the viability of aquatic-dependent species and to support geomorphic processes that create and maintain habitat. Flow criteria should consider the needs of each tributary's flow-dependent aquatic organisms and emphasize the protection of threatened or endangered species or species likely to become threatened or endangered in the foreseeable future. Flow criteria will then be used to develop flow objectives. Flow objectives, which have regulatory effect, will be developed to balance and protect public trust resources and other beneficial uses of water, such as agricultural, municipal, and hydropower uses. Flow objectives will be tailored to each individual tributary and address the unique hydraulic and geomorphic characteristics, public trust considerations, and other beneficial uses of water. It is envisioned that tributary-specific flow objectives will be developed by the State Water Board as a component of tributary-specific policies for water quality control. There will be multiple opportunities for stakeholder participation as we move through the Phase 4 process, which will be outlined further later in this presentation. So public trust. The concept of the public trust doctrine, or public trust, arises from the belief that there are certain resources that should not be owned by private parties, but should instead be held by the government for the benefit of the public. The State Water Board is responsible for the protection of public trust uses, including commerce, navigation, recreation, and habitat for fish and wildlife. The State Water Board must consider these responsibilities when planning and allocating water resources and protect public trust uses whenever feasible. The State Water Board must consider and balance these public trust resources with other beneficial uses of water, as discussed previously, and we're going to talk about beneficial uses right after this. So the focus of the Phase 4 effort is on fisheries and the processes necessary within the tributaries in the Sacramento River watershed. So beneficial uses of water. One of the State Water Board's charges is to ensure that the state's waters are put to the best possible use and that the public interest is served. In making decisions, the State Water Board must keep 3 goals in mind: develop water resources in an orderly manner, prevent the waste and unreasonable use of water, and protect the environment. The beneficial uses of water pertaining to water rights are defined in California Code of Regulations, Section 659 through 672, and are listed on this slide. In addition to these water right designated beneficial uses may also be designated in a basin plan. For waters within a specific area, a basin plan designates or establishes beneficial uses to be protected, water quality objectives to protect those beneficial uses, and a program of implementation to achieve water quality objectives. Basin plans designate beneficial uses in addition to those uses identified in the water rights section of the California Code of Regulations. And as you can see from this slide, the Water Code defines those beneficial uses, but does not limit them. And other types of beneficial uses that we see are cold and warm freshwater habitat, cold and warm water spawning, agricultural, and many of the same ones that we see as part of water rights. So that covers those four main definitions. Now I'm going to move forward with State Water Board background and authorities. So we're all familiar with the State Water Board's mission, which is to preserve, enhance, and restore the quality of California's water resources and ensure their proper allocation and efficient use for the benefit of present and future generations. Oops. The State Water Board has dual authority over water allocation and water quality protection. Water quality related work is handled by many divisions and offices within the State Water Board, including the Division of Water Quality and the Division of Financial Assistance. Water allocation and flow-related work, including Phase 4, is handled in the Division of Water Rights. Within its dual authorities, the State Water Board provides comprehensive protection for California's waters. In carrying out its authorities, the State Water Board protects and enforces water quality standards. And water quality standards are comprised of the beneficial uses, water quality objectives, and ensuring that there's not degradation of those waters. The State Water Board must consider public trust values in balancing beneficial uses of water in accordance with its authorities. So moving on to some recent legislation. In 2009, the California legislature passed Senate Bill X71, which was also known as the Delta Reform Act. The Delta Reform Act created the Delta Stewardship Council and also included some water code provisions specific to the State Water Board, as cited here. Water Code Section 85086 directs the State Water Board to develop flow criteria for the Delta ecosystem necessary to protect public trust resources pursuant to its public trust obligations. Water Code Section 85087 directs the State Water Board to submit a prioritized schedule and estimate of cost to complete in-stream flow studies for 3 groups of tributaries. Those 3 groups of tributaries were the Delta, rivers and streams to the Delta focused on the Sacramento watershed, and then all other water bodies in the state of California. In 2010, the State Water Board submitted the prioritized schedule and estimated cost to complete in-stream flow studies for these 3 groups of water bodies. The report included a total of 138 different streams and rivers, 28 of which were Delta tributaries. In 2010, the State Water Board also completed a report on flow criteria within the Delta. The report concluded that sufficient scientific information supports the need for increased flows to protect public trust resources. However, the flow criteria did not consider any balancing of public trust resource protection with other beneficial uses. And we're going to hear that again throughout the day, the idea that flow criteria are the technical basis. It's a technical number typically, or range of numbers to protect public trust resources, whereas the flow objective is where the balancing occurs. On May 16, 2013, the Delta Stewardship Council adopted its final Delta Plan. The final Delta Plan directs the State Water Board to adopt flow objectives for high priority tributaries in the Delta watershed that are necessary to achieve the co-equal goals by June of 2018. In the final Delta Plan, the State Water Board is also directed to implement flow objectives as soon as reasonably possible. So how are we moving forward with these objectives? The State Water Board is currently undertaking a 4-phased approach to complete Bay Delta activities. Phases 1 and 2 of the State Water Board's current Bay Delta effort will update the 2006 Bay Delta Plan. In Phase 1, the State Water Board is considering amendments to the 2006 Bay Delta Plan related to flows of the San Joaquin River and its tributaries, as well as Southern Delta salinity objectives. And the 4 tributaries that are being considered as part of Phase 1 are the San Joaquin River, the Stanislaus River, the Tuolumne River, and the Merced River. In Phase 2, the State Water Board is considering other potential changes to the Bay Delta Plan, including changes to Delta inflow and outflow objectives, export inflow objectives, Delta cross-channel gate closure objectives, Sassoon Marsh objectives, new reverse flow objectives for Old and Middle River, new floodplain habitat flow objectives, and other changes to its program of implementation. In Phase 3, the State Water Board will consider potential changes to water rights and other measures to implement Phases 1 and 2 of the Bay Delta Plan. And in Phase 4, which is the focus of today's discussion, the State Water Board will consider development and implementation of tributary-specific policies for water quality control for priority tributaries to the Bay Delta with focus on the Sacramento River watershed. While Phases 1 through 3 directly update and implement changes to the Bay Delta Plan, the Phase 4 work is a new State Water Board effort that will be separate from the Bay Delta Plan. Phase 4 goals. In Phase 4 of the Bay Delta effort, the State Water Board intends to develop flow criteria and establish flow objectives for a minimum of 5 priority tributaries in the Bay Delta watershed by June of 2018, and the remaining priority tributaries thereafter. This goal is consistent with the Delta Stewardship Council's final Delta Plan, which included the development of flow objectives for the Bay Delta and high priority tributaries as a key to the achievement of the state's co-equal goals. The final Delta Plan identifies an illustrative list of 5 priority tributaries in the Sacramento watershed for which the State Water Board is to develop flow criteria by June 2nd of 2018. I'll just point out again, I did say illustrative list, so that is not by any means the list or the final list. Phase 4 involves the development of tributary-specific policies that will contain flow objectives. The flow objectives will be designed to provide flows sufficient to protect public trust resources, maximize the beneficial uses of water, serve the public interest, and prevent the waste and unreasonable use of water. Key objectives for Phase 4 are to achieve a more natural hydrograph that takes into account the interannual variability, so we're talking about different water year types and magnitude of peak flows, and intra-annual events such as fall flush flows, winter peak flows, spring snowmelt, and summer base flows. Another key objective of Phase 4 is to restore the natural fluvial processes that inundate floodplains and side channel habitat, flush fines from spawning gravels in the fall, and create and maintain channel habitat. Phase 4 seeks to restore natural high flow recession rates to prevent stranding of juvenile salmonids, promote riparian seed dispersal, and trigger the natural reproductive patterns of key species. Additional objectives of Phase 4 are to restore self-sustaining resilient populations of anadromous salmonids and other native species. This includes addressing flow-related salmonid passage impediments, increasing the quality and quantity of salmonid spawning and rearing habitat, reducing water temperatures through increased in-stream flows to reduce stress on salmonids and other native species, and restoring natural aquatic habitat connectivity. We seek to preserve existing beneficial uses of water to the maximum extent possible while minimizing impacts to water rights holders. So what's envisioned for the Phase 4 process? Phase 4 involves the development of the non-binding flow criteria. That's the focus of today's discussion and workshop. Next, once we have the flow criteria, we'll develop flow objectives and implementation plans, which will include an adaptive management component. The flow objectives implementation plans will be included in the policies for water quality control, which will be tributary specific. And then we'll implement those policies through conditioning of water rights and other measures as applicable. So policies for water quality control, what are we talking about? So policies for water quality control are very similar to the water quality control plans that are adopted by the State Water Board and the regional boards. So we're envisioning that these policies for water quality control will be tributary-specific policies that contain flow objectives and technical supporting information. In general, policy will include the flow objective, the implementation plan, and adaptive management. The policies will establish principles, guidelines, and requirements for maintaining in-stream flows and habitat conductivity for the protection of public trust resources while maintaining the water supply and other beneficial uses, while minimizing impacts to water supply and other beneficial uses. Policies will be designed to complement or enhance existing water sustainability efforts. The goal of this work is to make significant positive progress towards the protection of public trust resources and other beneficial uses of water. To meet the Phase 4 goals and objectives, State Water Board staff identified the following objectives that a flow criteria method should address. The flow criteria method should be able to leverage the limited resources available to conduct needed studies over a large geographical area and use existing defensible scientific investigations and studies where available and appropriate. Additionally, the flow criteria method should be applicable to the bulk of each tributary's watershed and address multiple species or life-sensitive stages and fluvial processes while remaining responsive to the critical needs of salmonids and other threatened and endangered species. So this is the only nice map or figure you get with this presentation. So this map shows an overview of the National Marine Fisheries Service critical habitat for Chinook salmon in green and steelhead in red for the Sacramento River and North Bay Delta watershed. Steelhead and spring run Chinook salmon are threatened species, while winter run salmon is an endangered species. Fall and late run Chinook salmon are species of concern. Some of the flow-related issues contributing to the decline of these species within the current existing and potential habitat are reduced flows, timing of flows, and temperature. As you can see, there is a large number of tributaries that need to be evaluated and a limited amount of time available to help ensure species stability and recovery. One of the main questions we get from folks is this going to affect me? And when is this going to affect me? So the final list of tributaries has not yet been determined, but this is a list of the major tributaries shown in the previous map within the Phase 4 planning area. The State Water Board is currently working with the California Department of Fish and Wildlife, the United States Fish and Wildlife Service, the National Marine Fisheries Service, to prioritize these tributaries for in-stream flow criteria and objective development. State Water Board staff anticipates that the Phase 4 strategy document, which is under development now, will include a list of the targeted tributaries for Phase 4. This slide also contains which tributaries are being covered under Phase 1. So what have we done to date relative to flow criteria? In July of 2013, the State Water Board submitted a report to the Delta Science Program, as well as a request to get a flow recommendation for what method should be used to develop flow criteria. And in requesting that, we asked that the recommended flow criteria method or methods be scientifically defensible, cost-effective, applicable to the bulk of each tributary's watershed, and something that could be implemented in a timely fashion. The State Water Board also requested in the document that the Delta Science Program conduct a review of methods which can be used broadly, such as watershed or regional, at a watershed or regional scale. The State Water Board included overviews of 2 methods in its report to the Delta Science Program. One method was the in-stream flow incremental methodology, which is often referred to as IFIM, and as a regional habitat-based method. And then the other one was the ecological limits of hydrologic alteration, also known as ALOHA. However, the State Water Board is open to any recommended method that meets the needs of this effort. The Delta Science Program convened an independent review committee to conduct the review and provide a recommendation. In February of 2014, the review committee provided the State Water Board with a report and its associated recommendation. The material contained in this recommendation is the subject of today's workshop. The review committee chair, Dr. Cliff Dom, to my right, will present the committee's recommendation after this presentation. We hope to hear input from various stakeholders and agency representatives later today as well. So with respect to next steps, as mentioned previously, the public comment period for the flow criteria methodology ends at noon on April 18th of 2014. Staff will review the comments and information that's provided at this workshop, as well as part of that public review process, and developing a recommendation to the board on a method for flow criteria development. It's envisioned that the recommendation would be included in the Phase 4 strategy document. The Phase 4 strategy document is a roadmap for the Phase 4 process. And so it will include the goals and objectives and key elements of the Phase 4 effort, as well as an overview of the process and sequencing, the envisioned priority tributaries associated with Phase 4, and the flow criteria methodology. It's anticipated that the draft strategy will be released for public comment in the fall of 2014, and will be an opportunity again for folks to provide input into the Phase 4 process. So whereas today's workshop is focused on a very technical aspect of this process, the strategy in and of itself is more of a, as I mentioned, roadmap for how the Phase 4 process will move forward, and will provide stakeholders with a lot of information and the ability to comment on that process moving forward. So folks that are interested in staying tuned to the Phase 4 process, we have a webpage devoted to Phase 4. If you go to the Bay Delta main webpage, Phase 4 is listed there, so you can get to it that way, or you can go directly to the Phase 4 webpage at this link here. Folks who want to receive emails, updates specific to Phase 4 can sign up for the Delta Watershed Flow Objective, Phase 4 of the Bay Delta effort topic on our subscription list. And that concludes my presentation. Thank you.
Thank you, Erin, and this will be posted, right? So people will be able to get to that.
Correct. It'll be posted either late today or tomorrow.
Thank you for that overview. I'm gonna want that PowerPoint. So that way I can get it too. Some good slides in there. Are you giving her kudos for having a picture?
Well,
Okay,
I
good.
said the only image was the map, and there was one at the very end, and that was Deer Creek.
Thank you. It's good to know. That's better than, of course, I get nostalgic for the freeway overpass picture in the Caltrans report yesterday because I miss LA. That was really nice too. Thank you. For those who were here yesterday as well. Dr. Dom, I believe we're on to you.
In preparing for this presentation, I looked over some notes that I had from a previous presentation that I made to the board, and it came to light that the last time I spoke to you, and I believe two of the board members, Francis and Tam, were there at that point in time, was March 22nd, 2010, when we talked about setting flow criteria for the California Delta. So this is deja vu all over again, and hopefully I can provide some insight from what the committee did in review of this document, and with a focus on the tributaries of the Sacramento River. And before I get into the report and the recommendations in the report, I do want to provide you a brief background on the committee members. When I was asked to chair this committee, one of the things that I wanted to do was bring together some people that I knew had been involved in setting flow criteria in places where they had gone from developing flow criteria, vetting those flow criteria with the public, presenting that flow criteria to a board, having the board adopt these flow criteria, and actually implementing the flow criteria. And from my professional experience, the two places where this has probably been done as effectively in the United States are in the states of Florida and in Texas. And so the two people that I wanted to get involved in this from those two locations both graciously agreed. The first one was Marty Kelly, who has basically taken this whole process through to completion for about 25 rivers, one estuary, and I think 8 or 9 major spring systems in the Southwest Florida Water Management District area, which is the greater Tampa area. And so Marty was one of the committee members. The other committee member that I really wanted to get on board was an outstanding fisheries biologist from Texas A&M University who was very much involved in the in-stream flow criteria for all the major rivers in Texas. And so this is Kirk Weinmiller, and so Kirk Weinmiller was a member of the committee. And then I wanted some local expertise, because you have considerable expertise here in California. And a very good scientist from UC Davis, Sarah Yarnell, served on the committee. So those are the 3 committee members, in addition to myself, that prepared this. So I thought it might be of interest to you to know a little bit about their backgrounds. So let's start with a slide. I just wanted to spend a minute or so asking the question, why do we do this? I mean, why is it important to go about doing this? And there's quite a voluminous literature on setting flow criteria now. Really started in the 90s and is quite a large volume of literature. I glean 3 points that I like to make when I talk about these kind of issues. I've been involved in these kind of issues in Australia and in Europe, in addition in the United States, and there's a lot of effort on this, but I think one of the things that I would like the board to be aware of is there is a global crisis in freshwater biodiversity. This is very real. We have 0.8% of the Earth's surface that is in fresh water. It has about 6% of the total described species on Earth are in these freshwater systems. And these species, more than any other group of species, are either recently extinct, threatened, or endangered. About 40% of the total listed species worldwide fall into this bracket. So there's a real reason why people have put in concerted efforts to try to protect our freshwater resources. Another thing is that there's been some interesting large-scale analyses of late, and one of those that I'd like to highlight is a recent one here in the United States. And here in the United States, they really looked at the issue of what are some of the multiple stressors that streams and rivers face, and can we actually glean some information on what are some of the most important of these stressors. And this study, which looked at basically gauge records from all over the United States, found that when they looked at things like nutrients, pH, salinity, land use practices in the basin, the type of riparian zones that existed, and flow regimes, the one that had the greatest explanatory power in terms of understanding the integrity of the fish and aquatic invertebrate communities was diminished flows. And that was a fact. It was a paper published a couple years ago by USGS scientists. And then one other thing I like to make in these kind of public presentations is to talk a little bit about flow regimes. We tend to fixate often on volumes of flow, how much water. And the flow regime is more than just how much water. There are issues of when that water comes, how it ramps up, how it ramps down, what is the duration of certain types of flow conditions, how rapid, how frequent do these certain types of flows occur. And when you actually start talking about setting flow criteria, you need to consider all of these factors, not just fixate on volume or amount. So the committee charge were basically 3 things. We were asked to identify methodology that's scientifically defensible, cost-effective, that can be used representatively at larger scales, like a watershed scale, and that can be implemented in a reasonably timely manner. We were asked also on input on how recommended methodology or methodologies could be augmented or refined in the future. This is not a static process. It needs to be an active and ongoing process. And then we were also asked how to develop flow criteria that apply to the majority of a watershed, addresses multiple species, not single species, looks at different life stages of the aquatic and riparian the organisms that use those systems, and look at different fluvial processes. So that was our charge. And I'm going to cut right to the chase. Basically, here is the panel recommendation. As Aaron mentioned, 2 methods were presented to us for consideration. We looked at both those methods. We, in the report, tried to provide some information on the strengths, the weaknesses, and the uncertainties of both of those methods. We also talked a lot about our own personal experience in doing these kind of processes. And so we basically came back with a recommendation that the best approach moving forward would be to use a bit of a hybrid approach. Take some of the best attributes of the 2 methods. And so we basically set out a sort of 7-step methodology that we suggest be considered by the staff as a way of moving forward. Kind of the first step is gather together what you know about the systems that you're going to work in, classify them based on things like their geomorphology, what type of hydrology they have, what kind of a geographic setting are they found in, what kind of plants and animals exist within that system. So these are some of the things that you can usually do from existing literature, but it's important to do as an initial step. A second step is a detailed analysis of the hydrology of the system. Almost all of the systems that are being considered are systems that have plenty of long-term hydrologic data. So utilize that data, look at that data, try to glean good information on that data. Look at variability that occurs in interannual variability, decadal step variability, and look at also what role human modification has had in changing that hydrology. Third step is to look at to basically assess what's known about the biological communities that are there, and also assess if there's some key information gaps, because some systems are going to be reasonably replete with good data, others are going to not have that same level of data. Are there certain pieces of information you need to get? And if so, plan that early on, not wait till the last minute. And so make that assessment pretty early on in your process. The next step is trying to develop these flow ecology relationships. These methods are dependent on having information that link flow conditions with ecological needs of the species throughout their life history. And this is certainly one of the biggest challenges in doing this, but it's an important process. And it's also one that in some cases these kind of relationships are been developed for systems elsewhere that might actually be applicable here. So be aware of the literature, be aware of what people are doing in different locations. The next step is to produce an environmental flow regime that really looks at not just a single species needs, but looks at a multiplicity of species and looks at some of the key processes that are going on within the system. And Aaron already highlighted a few of what some of those things are, but things that basically inundate floodplains or move sediment or basically create new habitat, things of that type, which are necessary for a dynamic and living river to function well. And then finally, make sure that the process, start to finish, is transparent, open, and involves good communication with the stakeholders. And this is, I think, if it doesn't happen from day one, you're going to have real problems as you get towards the end of the process. And then finally, adaptive management comes into play. And there are uncertainties with this process. There are significant uncertainties with these kinds of processes. So make sure that you have an adaptive management protocol that's robust, well thought out, and that when further information becomes available, you can make decisions based on that information. The Delta plan has, for example, a section that actually outlines their approach to that. It might be useful to, for some of the State Board staff to look at. Okay, just some real quick highlights of how these other states have approached this problem. So let me start with Florida, and I'll start with the work that's been done in the Southwest Florida Water Management District. This is the statute. So I thought you might be interested in the state statute. This is what basically drove the process in Florida. The statute says that the minimum flow for a given watercourse shall be the limit at which further withdrawals would be significantly harmful to the water resources or ecology of the area. The key words there, I think, are significantly harmful. How do you define that? This is an operational definition that ultimately had to be made by the Water Management District. Their operational definition, which has withstood litigation, is basically that anything that reduces the habitat for the species in the streams and rivers that they've studied by more than 15% is considered harmful. And that was an operational definition that they used in setting these flow criteria. So that basically was the process that they used. They also used a process that I think all of us in the committee think is a useful process, and that is that they took the hydrology of the systems they were working on and they broke them into blocks. And they broke them into blocks, and then they looked at what goes on within those various blocks that are important biologically or ecologically. And so here is a typical blocked system. It happens to be a system near the Alafaya River. But basically, you see 3 distinct blocks. One of those blocks is when do you have the lowest flows. That's block 1. And in Florida, it's a very predictable time of year. It is in May and June. I think you're going to find a similar thing as here in California. It's probably going to be August and September. You're going to find that these will be the periods when you have your lowest of flows. Block 2 is an area of low base flow, not the lowest flows, but a period of usually fairly stable flows. Stability because this is the dry season in Florida. Then you have block 3. This is when the high flows occur. This is when the flood flows occur. This is the period of time when dissipating tropical storms show up. This might, you know, the analog here in California might be the time when an atmospheric river hits you. And so basically these are then the 3 blocks that are then looked at, and you map the life histories, you map the processes onto these various blocks. So that's the approach that was used in Florida. And then they link that to various aspects of the biology. And here are sort of the kind of the key groups that they worked on. They emphasized non-native and native species of fish because they have a number of invasive species that they were interested in, because you don't want to set flow criteria that benefits your non-native species if you're trying to set criteria that help your native species. They also looked at key aquatic macroinvertebrates that they thought were key parts of the food web. They also looked at riparian plants, because the riparian plant community is an important part of habitat for organisms that use riparian corridors. And they also, a lot of the work was on bird species, because of a lot of the public interest in Florida. We're on a lot of the wading birds and a lot of the riparian bird communities. So that's the way they approached it in Florida. Similar approaches have been done in Texas. This is again being driven by state statute. The state statute has now moved on with a new state law passed in 2007, Senate Bill 3, that actually has now required that the state of Texas begin setting flow criteria for all of their major estuaries. So they're in the process of now setting flow criteria for the rivers that drain into the 7 major estuaries on the Gulf Coast of Texas. And we've provided links to how they went about doing it. There's actually a very nice book that the National Research Council put out on setting in-stream flow criteria for Texas. That's a useful document. But anyway, this is the it's, you know, for your information. The information there is then basically the legal statute that under which they're operating right now in Texas. And they've done a few, I think, interesting things in the process. They have set up a statewide environmental flow science advisory committee. So they have one group that really is looking at the process statewide. They then have put together science teams for each of the 7 estuaries that they're working on. They've explicitly tried to address both seasonal and interannual variability. So how do you deal with these kinds of systems when you're in an extreme drought versus in a period of time when you might have you know, very large flood events occurring. They have some language like requiring that the estuaries continue to have sound ecological environments, that they basically have certain kind of key processes they want to keep functioning well, like good rates of primary production, habitat that is persistent and produces stable habitat for a lot of the life history attributes of the species. And then they also have stakeholder committees and state agencies that meet regularly to discuss the process. So they're in the throes of doing the estuaries, but they've already done their rivers. So if you're interested, you could look into some of the work they've done on the rivers. Finally, we have a little bit of information in the appendix to our report from work here in California. This is written by Sarah Yarnell, and I think there's some useful information. One of the things that Sarah's group has looked at, I think in some detail and written some very nice papers about, is the importance of the spring snowmelt recession as a very critical time for a lot of different biological species. And it's a very predictable period of time. And so there's a lot of organisms whose evolutionary history has evolved to make use of that as an important time to kind of complete key attributes of their life history. So that flow recession curve is an interesting one that you know, there's usually some ability to you know, maintain or mimic the historical conditions. They've also had an interesting study on Puda Creek, which I noticed was on Aaron's map, down here in the lower end of the tributaries to the Sacramento. It's a very nice paper where basically they basically returned a spring flood event to a system where it had been eliminated. Not a huge one. I think it was like 15% of the historical flows. So it was a fairly small, but it was a well-timed flood event. And they had, I think, 8 years of data on the fish community before, and I believe they have 9 years of data on the fish community after. And there was substantive improvement in the native fish community by doing that small adjustment to flows. And it's an interesting example of using a management tool to try to meet a biological end. And then finally, there's also some interesting ongoing efforts to try again to use adaptive management to reconcile various uses in the North Fork Feather River, and we use that example also for information for the staff and for the board. So one last slide and kind of some general points that I know that the committee and I would like to try to make, and that is we probably have about 80 or 90 years worth of combined effort working on these kind of issues, in the four of us. And so one of the things that we thought we'd do is just give you a few take-home messages from our experience. So, and I will quickly admit that a lot of this is drawn from some very nice work done in South Africa. So here are a few little bullet points. First one is that a modified flow regime should mimic the natural one, so that the natural timing of different kinds of flows is preserved. It is not identical, but a mimicry is useful. Most water should be harvested from a river during wet months. Little should be taken during the dry months. The seasonal pattern of higher base flows in wet seasons should be retained. Another one, that floods should be present during the natural wet season, but you can shorten the duration of floods. You can eliminate some floods and use them for storage, but don't basically take all the floods and knock them down. Leave at least some functionality relative to the floods. And so it's better to retain certain floods at full magnitude and eliminate others than to just basically whack them all down and have them all quite a bit smaller than they used to be historically. And one flood in particular seems to have some very key biological attributes that improve condition, and that's the very first flood that comes after an extended period of dry. And so a lot of people are calling this the first pulse flows. There's a lot of interesting things that go on biologically. There's a rejuvenation of nutrients, food resources, and basically a lot of cueing of organisms that say, okay, now it's time for me to move on to a next phase of my life history. And so that first flood can be very important after extended periods of dry. So those are some general principles I think that we wanted to communicate to you, and I'll stop there and open it up to questions.
Thank you. It was great. Questions?
Yeah, thank you for the presentations, and also thank you, Aaron, for the previous. In the discussions about trying to mimic natural hydrology that are ongoing, there have been some concerns voiced that what if we go to this trouble and yet all of the invasive species that now have populated the system have taken over, and we're just going to continue to nurture them. It was good to read and hear about the Puda Creek example, and I just wanted you to maybe expound on that, in terms of the experience in the other states where they've taken flow criteria to implementation, and if it's not completely selecting for native species in a short term, how the time frame we can expect of response, and maybe some reasons why we haven't seen responses yet, such as magnitude or those nuances you touched on, such as the first flush versus the magnitude of the peak flood event of that year.
Couple comments. One of the things that's really important in the initial assessment of whatever biological resource you're trying to protect is to address some of the questions you ask. What is the extent of non-native versus native species? In systems that are entirely dominated by non-native species, getting functionality back may have no effect on the native species if they're really largely been eliminated. So you need to know what kind of resource you have there. You also need to know about the life history of the non-natives versus the natives. Are there key aspects of spawning or provisioning of food when they're juveniles or cueing of migration patterns if they're migratory? It's knowing what those are for the native and the non-native species and seeing if there's some differentiation that links to what the hydrograph was compared to what the hydrograph is now, and then based on that make some decisions. Certainly there are systems where the non-natives are overwhelmingly dominant, and it will be very difficult to get native functionality back in some of those systems. In Florida and in Texas, in the Florida systems, I think there were certain important non-natives like tilapia that they were very concerned about trying to not see the populations expand substantively. In Texas, it varied markedly depending on where you were geographically. So some systems like the Rio Grande are heavily invaded. Other systems like the Sabine were much less so. And so the criteria that they selected and the recommendations as to what to do vary depending on what the biological community looked like in the system they were studying.
Yeah, and then that's very good. Thank you. I also note in the Puta Creek example the time frame for some demonstrative results, so measurable improvements in native composition were shown to be in about 4 years, if I'm remembering correctly. So that you don't see instant results from these mimicking of natural hydrologic processes.
Yeah, a very good point, and that's another thing about knowing something about the life history of the species you're trying to protect. Are they a 1-year fish, a 5-year fish, a 15-year fish? You know, what is the life history of those organisms?
First of all, thank you. Your report that was given to us earlier this year, it was excellent, and it has a lot of what you just said, but more detail, which is quite helpful. So that too is posted on our website. So I want to make sure that folks who haven't read it read it, because I think it's quite useful. In Texas and in Florida, where they actually have done a lot of these activities, how much education was there of the various stakeholders, in addition to stakeholder processes, which we have a lot of? But did they have some targeted education efforts, messaging, and community involved, community conversations?
I'm not sure in terms of formal education. I do know that in both places, Florida and Texas, it was engagement with the stakeholders at the planning stage and then commitment to continuing that interaction all the way through the process, so that there was a dialogue going on between the scientific community, the staff who were involved in putting together the recommendations, and the stakeholders that were potentially affected. And so they basically made sure that that process